Okay, so let's go ahead and pick up where we left off, which is right here, if I remember correctly. Okay, for some odd reason, I couldn't get the computer to work yesterday. What happens when we get into the microbiology unit, which is next semester, one of the applications we do is microbiology, okay? And with that, that's the study of different types of bacteria. And what you do is a culture stain, and the reason that we go about doing that aspect is that's what you'd have done in the doctor's office. If they really don't know what is being perhaps growing in the back of your throat, they may take a throat culture. Do some lab stains on there, looking under a microscope so you can actually identify the different types. Because typically when you come down with a type of bronchitis where you're coughing like that and you're producing mucus, it's usually a gram-positive bacteria that you can just take some antibiotics and that'll take care of the problem. Now, Salmonella, on the other hand, is a type of gram-negative bacteria, and that takes a little more work, but the problem with any type of bacteria, how many of us will make this correlation? How many, like Mountain Dew, Diet Pepper, Dr. Pepper, any one of those pops or soft drinks? Okay? What do you notice? It's got the caffeine in it. Typically, it's supposed to help keep you awake, right? If you consume that product. Well, what might happen is if you drink this at 8 o'clock and it keeps you awake for a couple hours, then about a month down the road, you drink your Dr. Pepper or whatever, and it's not keeping you awake. Now you got to drink 2. Now it'll keep you awake a little longer. Now we're about 4 to 6 months down the road. You drink your 2 Dr. Peppers and you can't keep awake. Now you got to drink 3 Dr. Peppers. What do you suppose your body is building up with that caffeine? It's not so much the immunity, it's a tolerance. Okay? Bacteria can do the exact same thing. They will build up a tolerance to different types of antibiotics and they lose their effectiveness. Yes?
What does coffee work when you only drink one? When you repeat the cycle?
It's just the caffeine in it. And that can build up the same type of tolerance too. Okay? That's why try to drink coffee in the morning, water in the afternoon. Flush all that out of there. Okay? So what you're doing is you are looking at that object either 100 times, 430 times, or 1,000 times. What happens, you have a different type of objective lens. Maybe it has a 43x. You take it times the eyepiece. 43 times 10 gives you 430. That's how you get to those numbers. These are, we've seen one of these in action. Okay? It's not any of these microscopes. It was called Hunting the Elements from last year, if you possibly remember that. They could actually look at an atom of copper. Okay? And you can do that with different types of microorganisms and actually see the inside of the cells. Or else how else would we know what the cell actually looks like on the inside? I mean, you can get a general idea with different types of magnifications, but these all have their different types of advantages. But just by looking at this, what might be the biggest disadvantage to this electron microscope if you are trying to look at specimens? What does it say they have to be? It's true about the cell. It has to be dead. That's right. So in order to see this, the cell has to be dead, and you can use this electron microscope. Different types of these are going to have different types of advantages. Okay? That's why you see so many different products out there. For some of you farmers, perhaps, I'm a Chevy person, Some people might be Ford people, but if you have a horse trailer or something heavy to pull, what type of model do you think is the pulling guru? It might not be Chevy, and it's probably not Ford. It's Dodge. Dodge is probably the big playmaker as far as those are some pulling machines, because that's what they're designed to do. Not everybody needs to pull a heavy trailer. So why would you want, not that you don't want to buy a Dodge, but why would you do that if you don't have to pull anything heavy? It's just not cost efficient. So stick with the Avalanche, the Silverado. Silverado's probably a little more common than that, I don't know if we want to call it steak and Avalanche, right? Why not? Yeah, it's got a plastic, maybe not plastic, it's a type of shroud in the back. It's just the looks. The problem with that is, even if the truck bed was a little longer, you can't pull a fifth wheel with it, or a horse trailer, because the turns just won't allow you to do that, and I think the box is too short too. But I kind of wish that we had a Silverado, but yeah, we'll keep our Avalanche. So just like every truck has its own function, every one of these microscopes will also have its own assorted function depending upon what it is you're actually using it for. Okay. Yes, I know it's warm in here, but like volleyball ladies, just wait, go to practice. It's probably warm in there. Guys in football, obviously, you got your pads on. It's going to be warm out there. Oh, maybe you don't? Okay. I don't know. But, yeah, I certainly feel it's warm, but your body will acclimate itself to it. So look at what some of these advantages are, okay? Okay, so these you can project on a screen. Look at the advantage of this scanning microscope. It can produce images in 3 dimensions, but it's got to be non-living tissue. So then maybe this electron microscope, that's a tunneling type. That might be the most common, because there you can look at live tissue. Okay, so probably a lot of these different types would be, of course, at universities or laboratories. You won't see these at the high school level, because we're looking at multi-million-dollar pieces of equipment, and it should be, because it's just that detailed work. It takes that type of technology to run that, which of course is not cheap. Unless you're Batman. I'm Batman. See? Yeah, I'm Batman. Shh. Don't let people know I'm Batman. Hey, that's not bad, is it? You like Batman? Spider-Man? Okay. Who's the best superhero? Is it the Hulk? Okay. Okay. All right. Yeah, fair enough. Cool shield and things, yeah. Yep. Okay. So, like a short answer question might be, why is the tunneling electron microscope useful for someone studying genetics? What's it tell you here? 2 things. One is, does the specimen have to be live, or does it have to be dead? It can be alive. And what's useful for it? What can you actually look at? You can actually see the chromosome makeup or its genetic material. That's probably one of the things that's, I would say, a little over a month down the road. It's a process called protein synthesis that deals with your specific DNA found inside your cells. Okay? Okay, I want to get through this one. I want to make sure that we get to section 7.2. Like I said, we're a little behind, but you people are quite capable of this. Oh, I thought I heard someone sigh and say, oh, go back. Okay. I don't know why it made this small, but
I didn't get the other one.
what, this one?
Yeah.
Oh. Okay, well, okay.
I'm sorry. I wasn't talking, I was confused because the title was different or something. I don't know.
Danny, more ready, less copy. Yeah.
So what's a typical classroom like back home? Nice and quiet and no one, no? Everyone's raising a ruckus and, okay. Maybe this is quiet, somewhat. Okay. Depending upon the day. Fair enough. Okay, now can we move on? Okay. Now, some people, believe it or not, would want to specialize in studying probiotics. Have you ever heard of probiotics? So that's something people are nodding their head yes. Okay? So when you hear that term probiotics, where do you suppose that is in the human body? Think about that while you're writing this short amount of content. That's too vague. We need to be more specific than inside the organs. Need to be quite a bit more specific. And there's no reason that you would know this. You just haven't been taught anything like this. Or maybe this has never come up, or has never come up in a conversation. Say that again. Oh, I thought you were answering where you find these. The heart? Nope, little lower. Little lower. Little lower. Intestines. Okay? What can happen, okay, if we prescribe too much in antibiotics, one, bacteria will build up a resistance to it. Two, you may remove some of the healthy bacteria inside of your stomachs, or excuse me, your intestines. Why is that important? That's why people eat probiotic yogurt, because probiotics are probably reintroducing what into your intestines? Well, whatever these are, what do we call them? Not just single-celled organisms. Starts with the letter B. Bacteria. You're reintroducing bacteria back into your intestines. So that way they actually functions for producing enzymes or reabsorbing water, whatever. Yes? Yes. Now, one of the aspects when we have a similar natured single-celled organism in our body that does not have a nucleus in it, it's red blood cells. Okay? So why do you think, don't take offense to this, you're not going to know the answer, but we just want to cause you to think. Just like back home, we want to make you think. Use our brains. Okay? What do red blood cells carry throughout the body? Oxygen. Okay? So, if you can remove just that little bit more of space, Now you can haul more oxygen. So it makes sense that red blood cells lack a nucleus. So when you take that space out of there, you can actually hold more oxygen. So that's an advantage to red blood cells being prokaryotic. Yes?
And you have bigger blood, big blood cells. Isn't that good for you?
No, they're typically the same size. They don't necessarily get enlarged. Because then they can't get into your capillaries. There's a fixed size that they can only get. Okay. Okay, I want to get through this, and then we'll see once what the next slide has, because we're all getting warm in here, and it's not fun concentrating. I get it. So just please be patient. I'll tell you what, we'll be done writing at the end of this, but we won't be quite done discussing things. Okay, so I'll put a little drawing up on the board to try to make sense of this. I know. Dihydrogen monoxide. It's good stuff. Can be expensive. It can be really expensive. But I like the cheap stuff.
Me too. What are we talking about?
Dihydrogen monoxide.
I don't know what it is.
You're going to hit yourself over the head if I tell you.
Coffee?
No.
Air.
No. Water.
Why don't you just say, oh, H2O? Yeah.
Because it's more fun this way to say this, no. It's just water. Well, sometimes we like to make things complicated. Okay. All right. So when we look at this, okay, does anyone change their own oil? Maybe yes, maybe no. You don't have to change your filter every time, but it's probably a pretty good idea, right? Okay. One of those things, don't run your motor low. Yeah, run your motor low on oil. That's really hard on them. It's about like you people running low on water and trying to maintain a high optimum level of athletic performance. It's pretty tough. Okay, so what this does, the plasma membrane kind of acts like an oil filter. It keeps materials out that do not belong in the cell. Does everyone have this content that wants it? Okay, not quite.
Bless you. What? Looks at you like you're not supposed to say bless you.
Are we good? Okay. Oh, remember this stuff?
Yeah.
Wasn't that fun?
It was actually just math, so it was pretty
Okay. This is going to lead into our final section. Okay? You don't need to draw this unless you think it's something that helps you. Typically, we would draw something, we say draw it, but don't feel so inclined that you need to draw this. Okay? Typically, when we're looking at a cell, okay? That's actually pretty good. It's 360 degrees. Kind of feels like that in here, don't it? We told a funny.
What? What, you told a funny?
I did. Well, why didn't you hear it?
These dwarfs are chucking things in my hair.
Don't say those.
Uh-oh, Brennan. Don't want to hear it.
Okay. Now, as we look at this, okay, plasma membrane is kind of like a gatekeeper. It filters things out, does not allow materials in that should not be in there. Okay? And there are 4 types. This is the final thing they're going to be talking about this chapter. It's terms that you've heard of before. Nope, there's 2 F's and 1 S. I can never spell this right. Oh, no, I was right the first time. Okay. So there's a clue. What's something else you might have heard of? What about this?
Osmosis?
Okay. And then there's this.
Yup. Yup.
And then this one's kind of by himself.
Drowning.
Okay. Now let's try to make this, I want to get through this as quick as possible, just so we can be done and disperse and kind of separate out, because it's getting hot in here, right? Okay? And usually when that happens, then we get a little agitated, right? Right. Okay. So typically what we see happening, the next thing we're going to be talking about is these different types of lipids that we see inside of here. Okay, probably the most important aspect of this, lipids are composed of fat molecules. Lipids are fats, okay? And what that means, are we all right? Okay. When we're talking about lipids, which are fats, these can get through the cell membrane quite easily, because if it's composed of the same backbone, it will, again, diffuse pretty easily. Think of it like this. You changed your oil or you've got grease on your hands. You go to the sink, put water on it, and that's it. Wash it off, right? You're saying no. You're correct when you say no, but why are you correct, though? Because water is a polar substance. Grease, oil are non-polar substances. Fats are non-polar substances. So what that means is if it's composed of the same type of backbone, it can diffuse quite easily. So if you don't put soap on here, or if you've got oil-based paint, you need an oil-based solution. Like what, maybe? Olive oil, probably. Mineral seed oil. Oddly enough, maybe gasoline. People, you can use gas to wash your hands. It'll take that off quite efficiently. But or you can probably do that too, because those are 2 non-polar substances. If they are like in nature, they will act a little easier, or what I want to say, break up the oil molecules. Then you can wash that off your hands. So each and every one of these has its own separate function to allow things in and out of that plasma membrane. It's warm in here. I've had enough. We'll pick up with this tomorrow. Catch up to you next time.